मशीन है, मशीन में जो वायर फीड हो रही है जनरली उसका डायमीटर होगा 1.75 mm। ओके, वो किसी भी कंपनी का हो, सभी इसी डाटा पे चलते हैं। एंड एट द सेम टाइम आपका जो नोजल का डायमीटर होगा 0.4 mm। क्यों? बर्नौली से अब जब भी किसी चीज़ को पीछे से प्रेशर करते हैं वो छोटे डायमीटर से आउट होती है तो एक फ्लो ऑफ प्रेशर बनता है। ओके, अदरवाइज एक कंसिस्टेंसी फ्लो में नहीं रहेगी। तो आपके पास एक ऑप्शन है मशीन टू मशीन, आप इस मशीन में 0.05 दैट इज 550 माइक्रॉन्स टू 0.32 यू कैन प्रिंट।
बेसिकली ये मतलब ये 500 लेयर डिसाइड करा है कंप्यूटर ने बाय इटसेल्फ।
उसने कैसे किया है, मैंने इसकी कैलकुलेशन बताया। अगर आप देखते हैं
मतलब हम लोग वो जानना चाहते हैं कि हम इसके लिए हम इनपुट देंगे
हाँ
कि डिजाइन में वो अपने आप से ले लेगा।
अगर आप देखिए ये पार्ट है आपका, जेड में ये कितना है सर?
90।
ठीक है, इसको इन्होंने क्या किया है 0.2 से डिवाइड कर दिया, 458 समथिंग उतना ही लेयर हाइट्स थी उसके अंदर। उसने क्या किया उतनी mm की हमने लेयर हाइट दी थी, उससे उसने डिवाइड किया उतना नंबर ऑफ लेयर्स आ गए। अब मैं अगर इसको और फास्ट में करना चाहता हूँ व्हाट आई विल डू, आई विल कम हियर, मेरे पास ये लेयर हाइट का ऑप्शन होगा, मैं इसको सबसे कम करूँगा 0.05।
अच्छा, लेयर हाइट कम होगा तो
टाइम बढ़ जाएगा,
टाइम बढ़ जाएगा ना,
पार्ट फिनिश
थिकनेस कम हो जाएगी ना, पूरी लेयर का।
अभी आप
डिपॉजिटेड रेट तो सेम है, आपने लेयर
का हाइट 1000 पे उतने ज्यादा
2000 1500 नहीं
लेयर हो जाएगी,
अभी कितने ही वो 2000 लेयर
पॉइंट देखिए मैंने
थोड़ा सा वेरिएशन है।
वही इतना जल्दी करना है अगर लेयर क्या है।
अगर आप बहुत ध्यान से इसमें फोकस करके देखोगे तो आपको
Layer।
बहुत ध्यान से देखने पे जाएगा, अदरवाइज 2000 नॉट विजिबल
तो लोग अच्छा रहेगा,
तो
इससे देख लो अच्छा आएगा।
बट अगर आप
डेमोंस्ट्रेट करना है
सॉफ्टवेयर फिनिशिंग
डेमोंस्ट्रेट करना चाहिए प्लीज इसका टाइम कितना 17 आवर्स।
तो आपके हाथ में है कि आप कैसा स्पार्ट करोगे।
लेकिन इसमें टाइमिंग ज़्यादा लगेगी, लेकिन मटेरियल तो कोई
Same
इफेक्ट नहीं आएगा, मटेरियल
Same
नहीं बढ़ेगा,
Same
बस सिर्फ मशीन रनिंग
दो
कॉस्ट
चार
बढ़ जाएगी,
2-3 उससे
थोड़ी रनिंग कॉस्ट बढ़ जाएगी
और सर इलेक्ट्रिसिटी
हाँ, इलेक्ट्रिसिटी का जो
यस। तो ये हम लोग ऐसे करते हैं 3D प्रिंटिंग में कि हम लोग एक ना बना के, मतलब इनिशियली और फिनिश पार्ट ना बना के वी विल मेक इट कोर्स। जब आपका डिज़ाइन फाइनल हो जाता है आप उसको फिनिश डिज़ाइन पे जाते हैं, वो हर 3D प्रिंटिंग प्रोसेस में हर सेम है। हम लोग कोशिश करते हैं पहले जितना सस्ते में बन जाए, पहले जितना अच्छा मतलब बिना पैसा लगे बन जाए वो बेटर है। अगर मैं अभी प्रिंट कर रहा हूँ, आप मेरे से कहते हैं कि मुझे इसके लिए माउंट बनाना है, मैंने भी नापा, मैंने मेजरमेंट्स करके डिज़ाइन किया, मैंने पार्ट शुरू किया, मुझे पता है कि अभी मेरा डिज़ाइन फाइनल नहीं है, मैं महंगा मटेरियल भी यूज़ नहीं करूँगा इंडस्ट्री में, आई विल यूज़ ओनली चीप मटेरियल। वंस माई डिज़ाइन इज वैलिडेटेड आई विल यूज़ कॉस्टली मटेरियल, आई विल मेक इट more tough। इस तरीके से मेरे पास एक मशीन में ऑप्शन है कि मैं प्रिंट देना चाहता हूँ, कैसे करना चाहता हूँ, मैं इसको रोटेट करना चाहता हूँ, मुझे ऐसे प्रिंटिंग है। बट अब इसमें इशू क्या होगा, इस पार्ट में होंगे भर के सपोर्ट्स, ये सारा पार्ट होगा सर, ये तो पूरे जीरो हो गए। तो अगर मैं इधर मुझे नहीं पता है कि ये लेगा नहीं लेगा, मैं क्या करूँगा, एक बार के लिए ना
चेक हो जाएगा।
सर ये some buildings की उल्टा कर रहा है पूरा बिल्डिंग, तो वो कैसे बनता है, किस बेस पे बनता है, रूफ जैसा जो
अरे अपना बैग ले लो,
बेस जो है वो रूफ जैसा बना दिया रहता है और ट्रायंगल शेप का नीचे कोई बिल्डिंग है ना, अनयूजुअल बिल्डिंग्स
basically what they do, they look like those are unusual buildings, but what they did, they made it in such a way that inside area is quite different. Sometimes they made like in Dubai, most of the buildings are very clean. कुछ ना कुछ वो नया try करना चाहते हैं, कुछ moving building कर रहे हैं, कुछ.
And that palm tree wala is structure, that thing.
So everything is generally pre-calculated, pre-thought software के through वो 2-3 साल लेके design करते हैं. Palm tree. So it's a very different thing. उन्होंने क्या किया, मिट्टी ली, कहीं से मिट्टी लाया, उसे डिपॉजिट करना शुरू किया. स्टार्ट डिपॉजिट. फिर कुछ जगहों में बड़े सलाइड आती है सॉलिड करने के लिए, तो उस तरीके से वो बनाते हैं.
Actually, what nowadays some softwares are there which will be helping us to identify the some malfunction of the design over a period of time. So is it possible along with the current technology?
मैम 3D प्रिंटिंग yes it's possible. You should be aware कि वो पार्ट की प्रॉपर्टी क्या है. If you can know the exact property of that part, generally when we print in metals, what we do, we print tensile bars, we print compressive samples, जिनका आप टेस्ट करके आप साइड बाय साइड आके ले सकते हो इसकी स्ट्रेंथ इतनी है. If we put that strength, those values inside those software, and we can able to get the same results कि okay इसमें इतना pressure daily basis पे लगेगा. So those software can
What is
predict.
available with this structure?
Not from this.
Not this one, but some softwares are available in order to identify the aging of this structure over a period of time, right?
Yes, relevant. So for that you require a lot of extra data. If something is conventional, so there is some kind of data for that as well. But sometimes there are things which cannot predict anything. Example, if you live in Delhi, you know about that old British which may have gone through its life 2 times of its life. So softwares can predict, but for that you require accurate data for everything. Okay.
If there is no documentation, then it's quite difficult to identify the.
Then in that case,
Predictions you need to-
tests are done. Some same case studies are performed where you have to sense, like if I will, just for example, click. Okay, I know I have designed this thing in such a way that click. How many clicks it will register? Like just like you asked, na, this how the software will predict. So what the company may have did, they have made some robot which will only do.
Okay.
Okay, it will record everything. They will get the data. They know they
Vibrations
have
and all.
yes. They know this mechanism will take this much clicks. They know this material will take this much of clicks. So as per those models, if they input all the datas in the software and they make a newer mouse on the basis of the same concept, they may get some answers, but they will do some kind of research work in that as well. If I give you an example, Burj Khalifa was made. So for Burj Khalifa, what they did, they designed the whole structure. Once they designed, they simulated that they know that in Dubai this much heat is there. In Dubai, this much winds blow. At this height they blow. They have calculated everything. They inputted that into a software. Then they inputted the structure they made. If you see, there is a very good documentary on how Burj Khalifa was designed. So it's again based on the honeycomb structure design. So they take all these things account. They did simulation. They did worst case simulation that a tornado will come, and as per that they modified the design. So this kind of work is done. If in the case of basic designs, we know NCS like softwares are there in 3D printing, not in 3D printing, in mechanical, where what happening if I want to calculate the load, we used to teach students the beam
Strength of materials.
yes, in the SOM, in the dome, we teach them this kind of beam is there, how much load it will be can bear, because that has been calculated previously. So generally not doing by hand, the softwares are there. You have to mention these things that this kind of load is there. They may have one, like it's like they may have done it once. Once they did this thing, they got some results. They have input that into software, and now everyone is going to use those results. So software can predict up to a mark, and once they made something, they will do their own level of testing. That is those simulations were up to the point or not. So they can modify from them. So again, that can be done from 3D printing as well. Okay. So just like this, we can just make us a file. We will put it into pen drive. We know we can give layer heights. There is one command where, if for example, you know this Buddha is there. In the case of Buddha, you are not going to throw it. You are not going to do catch from it. It will be just a
Less
showcase.
somewhere.
So you do not require to have its lot of strength. You require to have finish, but not of strength. You do not want it to have lot of infill material. You can control that in the part. So from making it a solid part to making it a hollow, you have flexibility to do that on your own. Okay. If I come here, I can give infill. I have an option where I can increase the infill percentage. I can make it solid. I can make it hollow. Again, it's in my hand, so I can do that. I can give temperature for the part. I can make supports. I can control speed. So everything for a part you can do using the software. So this thing you learn once you start doing this. It's not a very technical thing. Like if you see these specifically settings, you will see there are a number of settings. Some people will get scared, but the thing is that you do not have to play with lot of settings. You just need to first select the material. Like here is the material. Why when selecting the material, some settings were written by us, where we have mentioned the temperature for the part, where we have put some specific speed for printing. So from them, this will select. Then what kind of quality you require, medium, high, or fast. Again, same thing. Layer height will be reduced, print speed will be increased. You will see a faster part.
इसमें लेयर हाइट कितनी परसेंट कम या ज़्यादा हो जाएगी?
Basically, it's 30%. To be
ये
exact.
बाय डिफॉल्ट दे रखा है।
Yes, it's not by default. It's by us. We have tested
उसको भी
it.
हम चेंज कर सकते हैं।
Yes, yes. If I do not touch this thing, if I want to change the layer height, I will come here.
ये मैनुअल हो गया।
Yeah, manual हो गया. If I want to change that, as you said, what I will do, I will click on fast. But अगर मैंने in fast I have given 0.05 mm, which is the slowest one. I just click on the update profile. That will be saved in that profile.
So it will do the reverse thing.
Yes. Okay. So again, it's in my hand. Then I have to select the extruder, left extruder, right extruder, depending on you. Both will work same. There is no difference in that. If you are printing two colors, then you can go for both extruders. If you are going to print one with support and one with main material, you can do that as well. So it's in your hand. Addition, as I told, any material will shrink or expand according to heat or coolness for the part. So sometimes you require to give some kind of anchoring to the part. Like if I give the example, this is the part. Okay, just look very closely to this part. You see there is one extra line, layer of lines which comes. What is it doing? It's creating some kind of base for the part. If any kind of contraction or expansion happens, that will take care from outer to inner, not from inner to outer. So in that case, it will shrink. At certain point, the shrinkage will stop. Why? Because there is no room for movement. So the part will not get detached from the bed. So by this process or by giving some heat, there is you can print anything. So I need to just have a file. I will import the file inside the part. in the software, and by giving 3 to 4 commands. One command is first of all layer height. Again, it's in my hand. What kind of layer height I want to give? 0.15.2 is the standard layer height, which will give you optimum results.
This is in MM.
Yeah, in mm. It's written also. Okay. After that, addition. Generally, brim is okay with some layers, lines. Some different material require different kind of addition. Like there is one called raft. I will once click on it. Okay, so see this. Now what is happened? Like the part has some extra layers which should not be there. So what it's doing? Some material just like ABS, PETG, they may require more addition. This will not work from them because they will have a higher temperature difference. So this kind of addition will be with the part, and this can be easily removed once a part is printed. You can easily remove. This is not permanent. Even if you see this very closely, you see there is a tiny area. So what this gap is doing? This is making it a little bit in the air. So when I want to remove it, I can just pull it out. After that, infill is there. Again, remember setting is there. No need to work on it. Just select infill percentage. By changing that, I can change the density of the part. Support. If I want to change any settings from the support, I can do. But if I want to give the support to a part, there is this option, auto support. Once I click, the machine will create the supports automatically. In the adjacent of that, I have an option where I can give manual supports by hand. Okay, something like this, something like this. Again, in the adjacent of that, I have remove supports. If I click on it, it will remove support. Then other two options is like right now I have to click once for one support. Now if I will just click and let it move, it will create a number of supports for me. Similarly, click and then move. And if I want to remove support shortly, you do not have to do a lot of things. If you see, like I know this part, I am well versed with the 3D printing. I know this part doesn't require supports. There is a chance some area like ear, chin may do not have a good finish, a little bit. But that doesn't matter sometimes. Whole part will be perfect. The chin area doesn't make it that issue.
But the part that we are printing now is without support.
Yeah.
So which means that it will seek itself. It will set itself.
Yeah.
If it is required.
Yes.
Yesterday we were discussing if it is less than 45 degrees, then it will take itself some support. If it is more than 45,
It's less than 45. If it's more than 45, it doesn't require
it
support.
won't take, software won't take by it.
No, software will never take by itself. You have to just come here and click on it to create supports.
But these supports, where to put in, is decided by software.
Yes, and its threshold is 45 degrees. Even not 45, 49 degrees. If you see, so we can even change. If you see this, then you able to see. So by this method,
So which means that it is up to me whether I put the support or do not put the support.
yes. So it's again an educated guess. You see, if you do not know if this will support or not, go to layer view. Once you will go to layer view, again I can check it by layer process. Like how? I will come here, I will grow the part. Okay, I will grow the part up to 1 point. Okay, so you see this area, this specific area, the chin area, is being supported. If I just remove the support and I want to check that does my machine or does my part require support, I will just have to check layer by layer. Will it be printed? or there is a chance that part will be printed in totally air, so the material will not deposit. Okay, so as I told now, chin is not like chin has some angle.
Which means that it is upon the experience of the person,
Yes.
skills and experience, whether he gives or do not give the support.
Sir, experience or also by eye. If you see this area is above 45 degree until this point. After that, it's more like 30, 35 degrees. So in this area, I know this will make some marks, which is not good. I want to give the support, I can give that, but the supports will also going to give the mark, and I have to remove it. It will increase the time. So again, it's on me. For this specific model, I choose not to give support because I have printed it without giving supports in the past. So again, it's a trial and tested. Until unless you destroy 2 or 3 parts, you will not understand how it's done. This is the reality. Okay, but if, for example, this part originally is in this orientation. Okay, and check this part. So first of all, software will say that it requires support. It will
Which means that it also gives the guess.
yes. Okay.
One option is auto support.
Yeah, it's the same.
auto support एक option है, अब उसमें पता चल जाता है कहाँ support देना है.
Now see this.
It gives directly.
As per the machine, this part will be printed without any issue. But do you think this kind of part can be printed at any case? I will again check the layer view. Okay, see this. Can you see this? It's literally printing in air. These are things you have to be aware. And if this is not printed properly, how we expect the part, full part will be printed
What
properly?
is the peak portion?
This one?
Yes.
So this is the raft I told you about. Adhesion, a type of adhesion.
Addition.
Foundation is this.
So okay, so it will be creating by itself.
Yeah, we have given it. If I just untick it, check. So that is for adhesing the part to the bed plate, nothing else. That will be easily removed afterwards. Okay, again, if because this is a layer by layer process, if any layer goes down, there is a chance that whole part will go down. It's just like a domino, we will stack things on one another. If your foundation is not strong, it will not stay there like that. Okay. So after that, the other setting is that addition is there, infill is there, support is there, temperature. Generally, every single material have written on it which material will be printed on what temperature. We have made these settings before, like by hand. If I will just click it, I have changed it to PET sheet, then the temperature changed. If I will click on any other material like for nylon, it will have any other material. So generally, it's written on the spool. If you check the material, it's written on the spool. Otherwise, everything is fed in the system. Content 1, content 2 right now it's disabled, and bed as well. So the temperature for the material, different materials have different bed temperature as well. Okay. Cooling. This is something which I didn't discuss yet. Some materials tends to float too quickly, so they also require it to be cooled. It's not like अगर कोई पार्ट प्रिंट हो रहा है तो वो एकदम से टेम्परेचर ज़्यादा होने की वजह से उस पर स्टिक हो जाएगा, उसे कूल भी करना पड़ सकता है. तो PLA ऐसा मटेरियल है, उसकी अगर आप मशीन के देखेंगे सामने 2 फैंस हैं, लेफ्ट राइट में भी दो फैंस हैं। उनका काम क्या है, एयर फ्लो करना उसके ऊपर, और जो पार्ट मेल्ट हो रहा है उसे कूल करते जाना विद टाइम अगली लेयर आने से पहले। अदरवाइज क्या होगा, वो एक के ऊपर एक लेयर रह जाएगी। हर मटेरियल का कूलिंग डिफरेंट होता है। अगेन आपको सिर्फ मटेरियल सेलेक्ट करना है, कूलिंग ऑटोमेटिकली रहेगी। स्पीड मटेरियल टू मटेरियल डिफरेंट रहती है। जनरली आपकी mm/s में स्पीड होती है 30 टू आप 70-80 mm/s चले जाएंगे। जितना आप हाई जाएंगे उतना वाइब्रेशन क्रिएट होंगी, उतना पार्ट खराब होगा। ओके, इसके अलावा और कोई आपको सेटिंग्स की रिक्वायरमेंट नहीं है। बेसिकली देखा जाए ना, आपको एक शूटर की सेटिंग्स देखनी है, लेयर, एडिशन, इनफिल, सपोर्ट, टेम्परेचर एंड स्पीड। और इनमें भी 2-3 सेटिंग आप चेंज करके मशीन रनिंग पे ला सकते हैं। कोई भी पार्ट लेके आइए अपना, उसको इसमें डालिए और प्रिंटिंग कर सकते हैं। सो दिस इज द प्रोसेस। ओके, आई थिंक पार्ट हो गया। लेट्स रिमूव इट।
This is the camera.
सिर्फ उसी के ऊपर रखो।
अब आपने देखा कि निकालते समय ही निकल गया।
एक एक स्टिक है
सो यही अगर कोई और डिफरेंट पार्ट होता, डिफरेंट मटेरियल होता, तो एक पॉसिबल है कि स्टिक ही नहीं रहता।
क्या टेम्परेचर रहता है?
मैम ये मटेरियल 190 to 210 डिग्री तक बेक होता है, बट जनरली
दो टाइम रहता है।
आपको ये मटेरियल के ऊपर देखना है। जैसे अगर आप स्कूल में चेक करें थोड़ा सा क्वालिटी, उसमें मटेरियल की टेम्परेचर मेंशन
ये पोस्ट फिनिशिंग सही हो जाएगा, है ना?
यस, ये ABS मटेरियल व्हिच इज डिफरेंट मटेरियल।
इसको फिनिशिंग में कैसे लेके आएंगे?
ये बताइए।
सर सैंड पेपर के साथ
हल्का सा रब का सा।
हल्का सा रब करिए, आपका पार्ट हो जाएगा इजीली। इसमें जो ये थोड़ा सा आया है यहाँ पे, इसके आने की वजह भी ये थी, मशीन बंद हो गई थी बीच में।
हाँ 2 महीने से
नहीं
सर,
नहीं, ऑन करने के बाद
वो बीच में बंद हो गया था।
बैकअप नहीं था, बैकअप नहीं था।
यहाँ बंद हुई। चिन की बात।
चिन तो मैंने आपको बताया था सर, थोड़ा सा रहेगा चिन पे, बट इतना ज़्यादा नहीं रहा। वही मैं सपोर्ट देता, मे बी इससे भी गंदा होता। सो सपोर्ट इज़ अ वेरी बैड थिंग फॉर एवरी प्रिंटर। अब ये अच्छा खासा 50 ग्राम का पार्ट है। ओके, सो आप इसको सैंड करके फिनिश कर सकते हो, लेयर्स छुपा सकते हो, पॉलिश कर सकते हो। इवन आई हैव अनदर पार्ट जो
से अच्छा रहता है। How much it will cost in Archie gallery? Archie?
500-600 कुछ भी कर सकते हैं। Actually they will portrait in glass covering.
एक
Charge तो अलग है।